Hello everyone, welcome to Chemspires. Now we'll look into the exercise question 1.13. The question is, pressure is determined as force per unit area of surface. The SI unit of pressure, Pascal, is shown below, that is 1 Pascal is equal to 1 Newton meter inverse square. If mass of air at sea level is 1034 grams per centimeter square, calculate the pressure in pascals. So you should be aware of the pressure formula. It is nothing but force per unit area, that is pressure is equal to force by area. Let's write the expression. Pressure is equal to force by area. Force can also be written as weight, that is mg, mass into gravity, acceleration due to gravity. So it is equal to mg, mass into acceleration due to gravity, divided by area. In the question, mass of air at sea level is given as 1034 grams per centimeter square. That means it has been given as the mass per area. So in the place of mass by area, we can substitute it as 1034 grams centimeter inverse square. And the g is nothing but the acceleration due to gravity, which has the constant value. G is equal to 9.8 meter per second square. So in the place of g, we shall substitute 9.8 meter per second square. So in the question, they have asked us to calculate the pressure in Pascal, and let's see what we can do after this. So unit of pressure is Pascal. So 1 Pascal is 1 Newton per meter square. So 1 Pascal is equal to 1 Newton per meter square. Newton is nothing but the unit of force. And we know that force formula is mass into acceleration. So unit of mass is kilograms and acceleration is meter per second square, and force unit is Newton. So let us have it in a side and let's do the main part, that is 1034 into 9.8, and let's write the units separately, that's gram, centimeter inverse square, meter into second inverse square. So let's multiply the magnitude, that is 1034 into 9.8, which turns out to be 101332. So if you see, 1 Newton is kilogram, meter s power minus 2. So let's convert gram into kilogram, because we know that Newton meters inverse square is 1 Pascal and Newton is expressed in terms of kilogram. So let's convert gram to kilogram. 1 gram is nothing but 10 power minus 3 kilograms. So let's substitute it in the main equation. So we'll get 10 to the power minus 3 kilograms, and let's write everything as such, meter s power minus 2. There is a centimeter inverse square left out, let's write it also. So here if you see, you can find out. So first of all, we shall write the magnitude 101332 into 10 power minus 3, and if you see kilogram meter s power minus 2, what is it? It's nothing but 1 Newton, which we have derived in the side, and there is a centimeter inverse square, we are writing it also. Then let us convert centimeter square, that is centimeter inverse square, to meters inverse square, because 1 Pascal is Newton meter inverse square. So Newton centimeter inverse square can be written as Newton by centimeter square. So let's see what it turns out to be. Newton by centimeter square can be written as, so 1 centimeter is nothing but 10 power minus 2 meters. So let's substitute Newton by, in place of centimeter square, let's substitute 10 power minus 2 meter the whole square, since there is a square there. So it will be equal to Newton by 10 power minus 2 the whole square into meter square, which is equal to Newton by 10 power minus 4 meter square. So if you take 10 power minus 4 up, it will become 10 power 4 Newton by meter square, which is meter power minus 2. So let's substitute this in the place of Newton by centimeter square. So we'll get the answer as 10133.2 into 10 power minus 3 into 10 power 4 Newton per meter square. So 10 power minus 3 and 10 power 4 are there. So here already we have got in terms of Newton meter square, which is nothing but Pascal. So we have got. So let's see how to simplify the magnitude terms. So 10 power minus 3 plus 4 Pascal, it will become 1033.2 into 10 power 1. So the final answer would be, take the decimal 1 point forward, so 10133.2 Pascal will be the answer.